Everyone, and thank you for attending our Combining Various Electronics into a Cable Assembly webinar. My name is Keith Rujo, the Director of Marketing here at Epic. Before we get started, I just want to let you all know that you will be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel located in the control panel on the right of your screen. If we don't get time to go through all the questions, we'll make sure we do get back to you all via email. Also, we will be recording this webinar and posting it on our website, both the slides and the video recording. Our presenter today is Brian Morissette, our Cable Product Assembly Manager. Brian has over 35 years of experience working in the electronics manufacturing industry. He works directly with our sales team on cable opportunities while working closely with our customers to recommend appropriate cable specifications for their applications. Brian also oversees the design and manufacturing of all our cable assemblies and helps to work out any issues that may arise with quality service and products to our customers. Prior to Epic, Brian held positions in both business development and manufacturing areas. He has also held positions on the sales and manufacturing side of operations working for TE, Connectivity, AMP, and Madison Cable. So without further ado, I'll pass over to Brian.
Good afternoon, everyone. I'd like to thank you for attending this webinar. This afternoon, we're going to be looking at including various electronics into your cable assemblies, and what that inclusion really entails, and what benefits that you'll get out of putting the electronics into your cable assemblies. Today, as I mentioned before, we'll look at the current situation when it comes to including the various electronic components into a cable assembly. We're going to look at the types of environments that cable assemblies with those electronics included in them could be used in. We'll look at the techniques that can be employed to protect those included electronics. We'll go over an example of an assembly that does include electronics, and then we'll take a look at what the future holds, what we think the future will hold for cable assemblies with electronics in them. Let's take a look at the current situation. Cable assemblies, unfortunately, are usually the last component to be designed when someone is looking at any electronic system or any type of interface. Well, assembly is truly the system's lifeline. Like any chain, a system is only as good as its weakest link. If the assembly operates at a transition speed that is less than what the system was designed for, the assembly is going to hold back the overall performance of the entire system. This will cause wasted performance that was designed into the system. In addition, if the assembly fails because of poor design, the entire system will fail. An assembly is typically designed with what I would call a good enough mentality. What I mean by this is that the assembly is designed with a basic understanding of the stresses that the assembly will be exposed to, from the environment that the assembly will operate in, the performance that the assembly will need. And no thought really is given about what the future performance of the assembly will be. In most cases, a designer will look at readily available off-the-shelf type components and really make them work rather than investigating the best components to employ in the assembly to meet the demands of the application. Thought really should be given to the total cost of ownership of the system. How much revenue or how much downtime or how much of a loss of productivity will an assembly failure cause? It is an organization willing to take that risk for a good enough designed assembly. A designer really needs to give some thought to what electronics to be included into the cable assembly, what electronics the cable assembly will be connected to. By including electronics in the assembly, the termination points are controlled better. The cable assembly can be used to protect the electronics from environmental stresses, and the assembly can be used as a contributor to the overall performance of the system. Let's take a look at some of the environments that that a cable assembly that includes electronics could possibly be used in. Cable assemblies are used in almost every environment there is, from space to the deepest oceans and everything in between. These environments create many different situations that cable assemblies need to be designed to be able to withstand. For instance, if we look at a few examples, we can understand the issues that cable assemblies, any electronics included with those assemblies, have to face. For assemblies that are part of equipment launched in space, they need to be built small and as lightweight as possible. During launch, re-entry, these assemblies are going to be exposed to some really high amounts of vibration and shock. Going to be exposed to temperature cycles of extreme heat and cold. And they're going to be exposed to radiation when they're in space. For any electronics included within an assembly, the design will protect both the assembly and any electronics included within it. If we look at an assembly designed for use in a medical environment, for instance, it can be exposed to repeated sterilization using steam and pressure and high heat. The materials used in the design of that assembly need to be able to withstand those conditions, and the design needs to be moisture tight and protect the termination points and any electronics included within that. If we continue on that route, if an assembly is used in an industrial application, it needs to be designed to withstand exposure to different fluids such as petroleum products and chemicals or cleaning fluids, as well as dust and abrasion, physical impact, and extensive flexing and abuse. Including electronics into a cable assembly allows for the electronics to be protected in an enclosed environment. And with the connections also being protected, there's a lot less chance of problems due to connection failure. What techniques could we employ to protect those electronics that we're going to be putting in an assembly? And what do we do to help the assembly itself? Probably the easiest method to protect both the assembly, the termination points, and the electronics is using an overmold. Really an ideal method of protection. The overmold will provide fluid, dust, and a tamper-proof seal to the electronics, the termination points, and the junction of the cable shields and the connector body. Including a strain relief into the overmold will provide mechanical protection for the connector in electronics, as well as eliminate any stress points in or near the termination point. An overmold will also help to protect, to provide superior performance when you compare it to a slip-on boot or a pre-manufactured back shell. Those work to a certain point, but not nearly as good as a true overmold would do on the back of a cable and covering up a termination point. If you do them properly, an overmold will isolate the components from the outside world, as well as isolating them inside the overmold cavity. The protection that it provides will eliminate any possible wear damage to any of the components and prevent the cable from leveraging any of the termination points and causing a premature failure. Let's look at an example of some electronics that we've done to include them in assembly in the environments that this assembly was able to be used in. We recently worked on an opportunity where the assembly was to be used in a marine environment. This assembly was to include two printed circuit boards and be able to withstand the rigors of being installed in unprotected areas on the outside of ships and other marine vessels. Because of the exposure to the elements, the assembly had to be watertight, had to be able to work at all temperature extremes, had to remain flexible regardless of the temperature, and had to be able to not allow any growth of fungus at the cable or the overmold area. Because of the environment the assembly was used in, fungal growth was a major concern. The entire assembly needed to be watertight, but allowing the growth of the mold mildew was a concern from both a cosmetic standpoint as well as a concern about growth, the mildew growth penetrating the components that the assembly was going to be connected to. To establish testing parameters and pass-fail criteria, we use ISO 16869 as a guideline to arrive at our test plan. Our test plan consists of spraying the entire assembly with a suspension of mold spores, excuse me, and then placing the entire assembly in a mold growth chamber. The temperature of the chamber was maintained at 29 Celsius with a relative humidity of about 95%. The assembly stayed inside the chamber for 28 days, and after that time period was inspected for mold and fungal growth. If there was little to no mold growth, the assembly was considered as passing the mold growth test. As far as the water tightness test, this was also conducted on a completed assembly. The entire finished assembly was placed inside a water-filled tank and pressurized at 35 psi. The finished assembly remained inside that tank for 20 minutes, and then when it was removed, any excess water was blown off using pressurized air. At that point, once everything was blown off, we conducted a conductivity test to show if there was any water penetration of the assembly at any of the entrance points. On the end of the assembly were electronics that consisted of two printed circuit boards with pogo pins attached to the boards. These boards were used to control downstream circuits and needed to be held in place and be secure and be watertight. To not allow any movement of the board, we used a base plate designed to tightly fit the boards and keep them isolated from one another and also the outside world. The exit hole of the pogo pins, as well as the cable entrance and exit, needed to be sealed to not allow any moisture penetration whatsoever. To do that, we utilized seals around the pogo pins in exactly the right center space in the hole in there, and designed the entry spot of the cable with seals. As I mentioned earlier, the assembly was going to be installed unprotected on ships, exposing the assembly to temperature extremes as well as the environment. The cable needed to maintain its flexibility regardless of the temperature, and the customer had a stipulation that it could not remember any coiling that it had been exposed to either during manufacture or shipment or installation. The strain relief that was molded onto the cable, it needed to maintain its water tightness regardless of the temperature or regardless of the angle of bend that it was going to be exposed to. On the other end of the assembly were two pins that needed to be on the exact center spacing. These pins were used as both a connection, but also as the means to hold a connection in place by using a friction as retention. If one or both pins were not exact, the retention would be weakened and the connection would be lost. This end also needed to be watertight, so it was constructed by using an inner and outer mold of different but compatible compounds so they could bond to one another. The result of our design was that the assembly did not promote any fungal growth whatsoever. The seals that were developed allowed the assembly to be watertight to a depth of roughly 80 feet. Flex tests were conducted on the assembly, and flexibility was maintained throughout a temperature range of roughly -40 C to plus 115 C. So all of the targets that we had set for ourselves were easily, I can't say easily, but were accomplished through our design. Let's take a look a little bit at what we think the future is going to hold for us. Including electronics with cable assemblies provides for a more reliable interface. Because electronics are sealed and protected, they can withstand almost any environment that anybody could throw at them, and they allow for space savings on the equipment. The types of electronics that could be included with cable assemblies Technologies such as RFID tags or locking software can be put on panel cards terminated to the connectors to be in there. Battery charging electronics and fuel gauges of the battery can be built into the oval molds, as well as any type of LEDs. Switches could be attached to the oval molds or attached to the connectors through the oval mold process. And they can be of any design. It can be either included in the oval mold or attached to the cable if need be. Basically, the only limitations that we would have in the future going forward would be based on size constraints of either the molding machine or the area associated in the equipment where the assembly would be matched. So in summary, I'd like to close and say, including electronics and cable assemblies really does improve reliability. It frees up real estate on the equipment the assembly is going to be connected to. And it allows electronics to be fully protected from almost any environment. As assembly performance increases in the future, the inclusion of electronics into the assembly will increase to make everything more reliable.
Thank you, Brian. While Brian reviews some of the questions that came in, wanted to briefly mention some of the additional PCB-based products we offer here at Epic. Custom battery packs, Flex Rigid-Flex PCBs, high reliability user interfaces and cable assemblies, as mentioned in this presentation. Our energy-efficient fans and motors, and as well as our root product printed circuit boards. Next slide, please, Brian. So we also have facilities based all around the globe that specialize in each of one of our products. So for battery packs and power management, both here in New Bedford, Mass, as long as Denver, Colorado. User interfaces down in Largo, Florida. Our fans and motors is, again, both here in New Bedford, Mass, and also in Wales, UK. PCBs, both out of New Bedford, Mass, and Shenzhen, China. Flex and rigid flex circuits up in Toronto, Canada, and cable assemblies are also done in our Largo, Florida location. Next slide, please, Brian.
Okay, we have a few questions come in that I'll address now. And again, I apologize if I don't get to your questions now. I definitely will answer them over the next day or so. First question that came in was a question about the type or the size of electronics that could be incorporated with a cable assembly. Right now, the only factor that would determine the size of the electronics we could put in would, as I mentioned earlier, would be the size of the oval molding machine. We can get some very, very big oval mold or injection molding machines. So that is pretty wide open at this point. The area where where the assemblies are going to be connected to could be an issue. We'd have to worry about what type of weight that we're putting on that connector. If we get too big in size, we'll put electronics in there. And then we have to worry about the size of the shot of the mold itself. If we try to pump too much compound around the mold, cooling becomes a factor, which will cause some cosmetic issues if we're not very, very careful. So yeah, that was a good question. Next question came in, can we truly make an oval mold that's fluid tight? And then additional to that, what IP rating would be best for a fluid tight assembly? By using the right compounds that match very well with the cable compound and molding it appropriately over the connector, we can make an assembly, an oval mold, that is fluid tight, be it water, be it chemicals, be it cleaning fluids, pretty much anything. We can make it fluid tight. And as far as the IP rating, the highest IP rating right now is IP68. In the first digit, the 6 in that really designates particulates about getting in. And 6 is really tight. 8, it tells you how deep the assembly can go for exposure to water. I believe it's about 1 meter right now. But we've been able to build assemblies that go much, much beyond that. As the example I showed you, we were able to get down to an assembly that would handle pressure down to 80 feet. So we can make assemblies that are definitely fluid type. Next question, question 2. Who supplies the electronics when you include them with an assembly? Usually, EPIC will supply all the electronics that we need, given the different parts of our company, the different areas of our company. We do have the ability to be able to provide circuit boards to some of our customers for them to populate. If a circuit board needs to be populated, then we can include those into an assembly. If they use interfaces, we can get those from our internal sources. So for the most part, EPIC supplies all the components when we include anything into an assembly. One additional question, and we'll let it go. Question is, if electronics are included with assemblies, are they tested before and after they are put together? The answer to that question is yes. We will fully test everything before we overmold it. And then once it's completed, we will perform a test on the components as well as a test on the finished assembly to make sure that there's no poisoning or no contamination of any of the components when we do the overmold. So we do fully test everything that we put into or include with an assembly. But that were all the questions that I had in, and I want to thank you for attending the webinar. And again, as I mentioned, if there's any additional questions, feel free to send them along, and I'll answer them over the next day or two. Again, thank you for your time.